Okay, we're going to look at finding the volume of a solid, but there's going to be different methods to how you do that. And so in this video, we focus on just one method, the method of finding the volume by cross sections. There's other methods. Let me just quickly tell you what they are, and these will be handled in separate videos. If you have a solid that's formed by revolving a region around an axis, then there's these three methods here to find that. The first method, volume by cross sections, is not a revolution. And then one last thing, these first three methods together can be categorized as finding volume by slicing. Okay, so today we just focus on this first video, this first section here, volume by cross sections. So what's the method? So I have this shape. I like to find the volume. It's a three-dimensional shape, and I'm going to find the volume by slicing it. In this particular picture here, I'm slicing with a plane called PX. This plane is perpendicular to the x-axis. And so I'm going to slice perpendicular to the x-axis, and what I get out on that plane is this red shape here, and it has an area. That area can be described hopefully in some formula based on where x is. And we want to find the volume of this solid. So we're going to cut it into many pieces, and we're going to find the volume of each piece, and then after that we can basically add all of those individual pieces up to get the total volume. Okay, we'll treat these pieces as cylinders. Now when you think of a cylinder, usually you just think of two circles and then connected with a certain height. Well, this isn't quite that, but if you have two bases, which we have here, and the height will be some for this particular shape will be some small distance, and the bases of these cylinders will be cross-sectional areas. This A of X area. Okay. Now let's see how we can develop the formula. So the volume of each cylinder is going to be found by taking the area of a cross section. So I'll have this formula, and I'll be able to plug in some x value and spit out the area. Okay, let's take a look at the picture. So I have some xi star, some generic place in x between some x equals a and x equals b. So I have this xi star, and I slice with the plane, and I get this purple, this red purple kind of shape here, and I'm going to treat that as a cylinder. It's going to have some thickness called delta x. That's going to be the height of the cylinder, and then the bases are going to be these sort of shapes. Looks like a loaf of bread, actually, right? And so I'm going to find the volume of that by taking a bunch of these slices and adding them all up. So here's a picture with 7 such slices. We have 3 on one side, 3 on the other side, and 1 in the middle. 7 pieces of bread. And our goal is to get the volume of the entire shape. And so we have to then add up the volume of each individual guy and take the total volume. So how can we represent this using calculus? So each individual guy has a volume of the area of the base times the height. When you find the volume of a cylinder, it's the area of the base times the height. And so this is our base, this shape here, and it will be described by the formula A of x. In this case, it's xi star, just for notation's sake. So I have this area of the base, and I multiply that by the height. And that'll give me the volume of that particular slice. So I have 1, 2, 3, in this picture 4, 5, 6, 7 of them. So in this picture n is equal to 7, and I sum the 7 volumes, and I get approximately the entire volume. So how can I get better? This is off. It's not smooth, so this is off, and it looks like this will be some under approximation to the actual volume of the shape. So how can I get the exact volume of the solid? Well, I could take more slices. The more slices, the better the accuracy. So this 7 slices, it's good, but it's not good enough. So we take more. What do you mean more? So we can take the number of cylinders, basically, with calculus, we can let that go to infinity. So this n, which represents the number of cylinders that you have, we're going to let n go to infinity and take a limit. Because what's going to happen, think about it, the more I have, the thinner they are. They're not as thick. And so what's going to happen, this height of the cylinder is going to be very, very small. Infinitesimally small, it's called. And so I have this exact now volume formula. And I'm going to let the number of slices go to infinity. This is called a Riemann sum, the limit of a sum, in this case, where xi star is just some place where you decide to evaluate on your individual cross section. It's some place where you decide to evaluate your area, and then you multiply that by the delta x height. So now we have an exact formula, and it's going to be now equal to this integration. It doesn't have to be in terms of x. It could be in terms of y if my slices were perpendicular to the y-axis. So I can find volume of a cross section by integrating. Okay, this is a Riemann sum here. Okay. All right, great. Let's take a look at another picture here. So there's a great website that I'm going to go to and show you these demos where they have the visualization of that static picture, these static pictures that we have here. And so with each different shape, it depends on what kind of shape comes as the cross-sectional area. Here, this is a semicircle. Here, these guys are equilateral triangles. These guys are just squares. What's different about this is that these squares are perpendicular to the I guess the z-axis here. This is a three-dimensional, and so we have to figure out how to do this one. But I just want in this video to show you the idea, and then later we'll work on examples. Okay, let's take a look at the videos. Here's our first video, that pyramid shape. So here's a video by this math demo website by a professor from Temple University. This is a video of how the volume is calculated. Each time we take a slice, in this case parallel to the z-axis, or perpendicular to the z-axis, and we get this pyramid shape. Each time we have a square, and we have to find the area of the square. We multiply by the thickness there. Okay, here's another picture, another movie for the other picture, where each time we have semicircles. These are the slices. We find the area of the semicircle based on the placement of the shape, and then we integrate that to find the total volume. Much better than a static drawing. And then finally the last one, this is an arc of sine x from 0 to pi, and now these shapes are going to come out of here as equilateral triangles. And it's going to be our job to figure out the volume. Okay, in separate videos we'll do the calculations. This video is just a concept video where we just get the idea. And so each time it's our job to figure out the area of the cross section based on x or on y. And so in a separate video we'll calculate, we'll see how to calculate the area of an equilateral triangle, the area of a semicircle. But for now, this is just the idea of finding the volume by cross sections. Okay. We're doing slicing, but the slicing are cross sections. Okay, great.